All right, today we have Sadia from Nimbus Engineering. She's going to cover all the basics of sustainable urban drainage with us today, and really draw on her experience from Nimbus, which are at the cutting edge of environmental engineering. So we're going to cover what is SUDs, why we need them in their planning proposals, and why we should be including it in the design aspect as well. It's really enough from me, so I'm going to pass on to Sadia and she's going to go over her presentation. If you guys have any questions, pop them in the chat box. We'll probably have about 5 minutes maybe to go over them, so we can go over them really quickly at the end. Over to you.
Thank you, and thank you everyone for coming. So today I'm just going to give you a bit of a guidance on what SUDs are, how they work, and how you can fit them into your proposed development of respect, regardless of what size of your proposed development. So here's our complete guide to sustainable urban drainage systems, or SUDs as they're known for short. So initially, I just want to go through what SUDs are and how they work. So here's something that I've taken from a website called Sustrain, which is a valuable resource for anybody who wants to know a bit more about SUDs. Now, SUDs work by mimicking natural drainage regimes to reduce surface water flooding by reducing peak flow rate and volume of surface water runoff. So you have specific types of measures, and I'm sure plenty of you know about things such as porous paving. Here you've got rain gardens. So that's just trying to deal with it as soon as it hits the ground, maybe slow down the rate of it before it goes anywhere else. And then following that, there are specific site control measures such as attenuation or infiltration, where that is feasible, where the ground conditions allow. And on larger sites, you will have regional control methods, which can be provided as a secondary treatment measure, as well as attenuation for extreme rainfall events to stop downstream flooding. Now, SUDs work by improving water quality. So basically, they treat the surface water runoff before it enters our watercourses and rivers. They also provide amenity value by introducing flora and fauna, make our spaces just look that much nicer, especially in densely urbanized areas where historically they've all been paved over, you know, lots and lots of buildings. So they do that, as well as increasing biodiversity at the site, which is, as we all know, very much needed. Oops, I'm going to go back. So why do we need SUDs? So increased climate change coupled with extreme rainfall events is causing flash flooding. That, coupled with increased urbanization, is actually overwhelming our existing drainage networks. Go back to space. So basically, traditional pipe systems is what we've been working with previously. These work by removing the surface water from our developments as quickly as possible. These cause increased downstream flooding and sudden rises in flow rates and water levels in watercourses. These also contribute to a reduction in groundwater levels and dry weather flows in watercourses, as well as reducing amenity value and adversely affecting biodiversity due to the surface water runoff containing contaminants such as oils, organic matter, and toxic materials. So I'm going to take you just to kind of explain why traditional pipe systems are not working for us anymore. I'm taking you back to last summer, some flooding that happened in London last year. I've got some YouTube videos that I have asked for permission, and they were just recorded by some residents. So if you look here, there's no flooding in that area, it's kind of moved. This surface water flooding is happening in a naturally low-lying area of that road. The drainage network is clearly overwhelmed. It can't take this rain anywhere. So all that's going to happen is going to come out the gullies, coming out the manholes, and it's just going to pond there and possibly keep rising, entering people's properties, causing quite a lot of problems to residents, car owners. You know, you can see cars trying to drive through flood water. It's not really advisable. It can flood the engines, but you know, people need to get from A to B, so they've got no choice but to do that. just take you to another secondary video. This one, flooding's quite a bit deeper, not necessarily just a small area of low-lying area. As you can see, it's starting to reach people's front doors. Here you've got a wee guy who's just trying his best to desperately take that water out of his building, but it's just going to keep coming back in, and it's really, really quite sad because, you know, once somebody's property has been damaged, we all know insurance companies do not like to pay out. So therefore, once you've put in a claim for flooding, it's going to be really difficult to get any kind of insurance from your property again. The next video, I think most of you might have seen, it was all over the papers last year as well. This was some flooding in a tube station, Hackney Wick. Hackney Wick is in a flood. A lot of Hackney Wick is in a flood zone anyway, but this just goes to show that once the drainage network is overwhelmed, I mean, luckily there was no risk to life. Nobody, you know, there were no injuries or anything caused by this, but you can see how this could cause a risk to life, and as well as the amount of damage, making sure that tube station is, you know, put right before anybody can use it again. All this, you know, causes lots and lots of problems. So that's pretty much typically why we need SUDs. So I think I need to kind of go through the SUDs hierarchy and the types of SUDs that should be utilized. Now, SUSTRAIN, again, as I've talked about, is a good resource on why, and it explains why the SUDs hierarchy needs to be used. So there's different, they look at different steps. So the first steps are rainwater reuse as a resource. So in this case, we've got rainwater harvesting. So this one is an underground rainwater harvesting tank. You see the downpipe conveying that surface water runoff from the roof into that rainwater harvesting tank. Some of this is being used for grey water, washing machines, toilets, and then some of it will be utilized for watering gardens, washing cars. Now, I don't think we had one last year, but we've had summers where there have been hose pipe bans. So this is a great way of making sure people are holding that water back, especially in dry summers, and then it can be reused and we're not putting the pressure on the water main system. Now, rainwater harvesting tanks can come in several forms. What I've shown you previously is kind of big tanks. They can be quite expensive, but these ones are just quite cost-effective ways of just providing slimline rainwater harvesting tanks. As you can see, they don't take a lot of space and they can just be retrofitted from the rainwater downpipes, used for watering the garden and washing cars. Secondary on the SUDs hierarchy, green roofs. Now, as you can see here, a lot of this flat roof has been utilized for green roof space. And what green roofs essentially do is they provide a level of treatment to treat some of the contaminants from that surface water, from that rainwater, but they also reduce the peak flow rate of surface water runoff by 50%. So already by providing these green roofs, you're reducing the rate of that surface water runoff entering the pipe systems. So already you are making a difference. The next on the SUDs hierarchy is infiltration. This provides groundwater recharge in soakways, permeable paving, infiltration basins and swales. Now, this can only be used where the ground conditions permit, where infiltration is feasible. However, in the case of soakways, infiltration basins and swales, what you're doing is you're putting the rainwater, the surface water runoff back into the ground, and therefore nothing is actually leaving the site at all. Here you can see some permeable paving, and this is just generally, again, these images are taken from SUSTRAIN. This just shows how the water just permeates between the permeable paving blocks through a kind of a sand soil mix, and then through a gravel sub-base layer, which provides a little bit of attenuation before slowly being released back into the ground. Here you've got a natural swale. Surface water runoff from hard surfaces is just being drained into this swale. Obviously, you can see there's a bit of an area in high rainfall events. You've got a nice bit of attenuation that can be kept there before it goes back slowly into the ground. So when infiltration can't be utilized, because it can't, you know, a lot of our country is clay, so the water is not going to go anywhere. So the next stage is rainwater attenuation in green infrastructure, detention basins and swales. These tend to be utilized more for the larger developments. And here you can see a nice detention basin, all the surface, you can see the large pipes there, all the surface water runoff from all these houses is going into this detention basin. There is space for high rainfall events to hold that flow, and then it will slowly be discharged back into the surface water network. But at least it means that a huge volume of this runoff is held back here instead of ending up in that sewers and flooding someone's road and property. Here you can see a swale, fairly deep. Again, these rainwater downpipes will discharge into there. All this development will probably discharge into there. You've got nice plants in here as well as here, providing lots of amenity value. And then there's all this area to provide storage during high rainfall events, again, to stop it going back into the surface water network and causing issues further downstream. Here are some rain gardens. These tend to be smaller SUDs measures. They tend to be kind of more of a source control measure. They tend to be also used quite a lot in schools. So here's a school. You've got all this area here that is utilized as a rain garden. It may not look particularly deep, but this is probably about 0.4 meters deep. And all these plants here are designed to soak up that surface water runoff and also clean it. The plants that are utilized in rain gardens are also plants that flourish in very dry and very wet conditions. So they're not going to get damaged by extreme levels of rainfall. And if it's, you know, hot, dry summer, they're not going to get damaged either. Here's another typical rain garden that is used, say, for something like a minor extension. So you've got your rainwater pipe, it's going down this water butt, and then you've got the outlet, and then it just flows down into this small area where some of the plants will soak up the runoff, they'll clean it, and then it will just infiltrate into the ground. So next, falling quite lower down on the SUDS hierarchy are attenuation tanks. Now, this may be very low down on the SUDS hierarchy, but they're probably the most commonly used. The reason for that is developers don't have a lot of available space, especially on the kind of smaller sites, highly urbanized areas. They tend to prefer the underground attenuation tanks where the flow is held back in the sealed underground attenuation tank. Consists of crate systems. You've got the surface water runoff entering, and then you've got the outlet that goes to some kind of a flow control device. So a certain amount of runoff enters, and then it's restricted, which means this structure can hold back what's left over. Once attenuation has been utilized, which is the lowest down in the SUDS hierarchy, the first step has to be controlled restricted discharge to a watercourse, because obviously our pipe systems convey that flow to the water courses. It makes more sense to take it directly to that watercourse rather than utilizing these pipe systems, which may become overwhelmed. Should a ditch or a watercourse not be available, we restrict that flow and we discharge that restricted flow to a nearby surface water sewer or drain. Should that not be available, then the last available option is to a combined sewer. So again, it is being restricted, but it's going into a combined sewer as well. The reason the combined sewer is lowest there is that obviously if there's any combined sewer flooding, it's a lot more damaging and detrimental than any surface water flooding, mainly due to the fact that there's a mix of foul flow in there as well. So that is a very quick guide to SUDS. And before I open the floor to any questions, I just want to go through some frequently asked questions that we get regularly asked, probably on a daily basis, to be quite honest, when people want to do a SUDS report or do some SUDS design. And one of the first questions is, you know, SUDS cost money. There's no getting away from that. They will cost money. So one of the questions we get asked is, why do I need to provide SUDS when all I'm doing is knocking down one building and replacing it with another of the same area. So the answer to that is, let's go back to the London floods last year. If we do not start restricting the flow from all new developments, all we're doing is making matters worse in the already overwhelmed drainage networks. Now, if all new developments can start slowing down that rate of runoff, then we are at least reducing flood risk at the site and elsewhere. So that is why everybody has to provide these now. There's no ifs or buts. You can't argue it with the local authority. There is a reason why these need to be utilised. Another question we quite often get asked is why are you using the permeable paving area in your calculations for attenuation? So a lot of developers will say, look, but we've got this huge area of permeable paving. Surely that, you know, the water's just going to go into the ground. So firstly, permeable paving only really works in low rainfall events. You know, as you can see through one of the other slides, it flows through the blocks. So any high rainfall event, that water is going to start running off that hard surface. At that point, it will enter a slot drain, and that slot drain will have to go to any infiltration or attenuation device. So we do have to count that. Another question we get frequently asked is, why do I need an attenuation tank? Can I just put a rainwater harvesting tank in? The answer is no. The reason for that is a rainwater harvesting tank relies on reuse. Now, if someone goes on holiday for 2 weeks, that water is not getting reused. Any extreme rainfall event that comes in during that time will then just overwhelm that rainwater harvesting tank and go back into the pipe network at a high rate. So it is something that needs to be utilized, but it does not count as attenuation. And the last one, as most of you will be aware, SUDs reports are frequently being asked for at planning application stage and for planning condition discharge. If the underlying geology consists of chalk or sand or a mixture of silt and gravel, then ourselves and the lead local flooding authorities will want to know if infiltration will work at that site, because that means there's no surface water runoff entering the sewers or the pipes. In order to do that, you need a BRE 365 infiltration or percolation test. This calculates the rate of infiltration through the soil. Without this information, we can't tell you if soakways or infiltration devices are feasible, and we can't also size these structures, so we can't actually design them. So it's not a case of just, can you just guess it, which we quite often get asked to do. Anyway, I will now open the floor to any questions you may have.
Oh, that was so brilliant. And it's great for you going through your frequently asked questions. I'm sure that's probably cut some of other people's questions out already. But if anyone does, either unmute yourself and you can ask it straight away, or you can pop it in the chat box. If not, I did have one. I feel like you kind of already covered it just there, but if someone got a retrofit the slimline rain harvesting system, is there like a high possibility of it overflowing? Would you constantly have to be making sure?
No.
Okay.
The way it connects is you've got a pipe from the rainwater outlet going into the tank, and then you've got a pipe going out of that. So there's an overflow. There's an overflow.
Okay.
That water isn't reused, it just goes in a loop and goes back through.
Okay, fair. Does anyone else have any questions? Richard, do you want to ask yours?
Yeah, hi, thank you. Great presentation, really insightful. Thank you very much. It was a quick question. We've got an example. We've got quite a tight site which has an existing commercial use. I'm looking to put some residential units on it. Obviously, the go-to answer is the attenuation tanks, because we don't have very much room even for the gardens. What I'd like to encourage is a bit of a mixture of everything. So rainwater harvesting. I love the idea of rain gardens. I think that, they're fantastic. And that would ultimately reduce the size of the attenuation tanks down. Is that something that the planners are welcoming, a kind of a mix of everything?
Very much so. Now, rainwater, we build hydraulic models of the systems when we produce our design. So we model rain garden planters as bioretention. So you don't need to have just an area, as you said, it's a tight site. So you can actually have planter boxes that just go down from the downpipes, and these just slow that rate of runoff. So eventually you've got less entering that attenuation tank. So all these little steps will actually save the developer money.
Awesome. Great question.
Thank you.
If no one else has any other questions, I'll end the recording here. I'll get it up on YouTube. Feel free to share it around if you've got other colleagues that feel like they need to learn a little bit more about SUDs as well. But thank you so much, Sadia. It was amazing, really, really useful. And it's great to understand the basics and hear what all the questions you've been asked over the years.
There's many more, but I didn't have time for that. So all good. Great to see you all. Thanks very much.